Okay, now we're going to talk about section 4.2, graphing some of these lines that we talked about in 4.1. We're going to be using the intercepts. We're going to learn what intercepts are and how to use them. So for linear functions or linear equations, we got the form ax plus by is equal to c. These are straight lines as long as a and b are not both 0. If they're both 0, then we don't have an equation, we just have a dot. So when we write equations in this form, we call that the standard form of the equation of a line. We can use this standard form to find our intercepts, and then we can use our intercepts to graph. So the x-intercept, you can read the text here, but I'm going to tell you real shortly that the x-intercept is just the point that your line crosses the x-axis. So just remember that x-intercept crosses the x-axis. The tricky thing about the x-intercept is y is equal to 0 at that point. So we have no height in our graph, right? Right at this location, our coordinate's going to always be an x value and y equal to 0, right? Because y is 0 all along the x-axis. So that's the important thing to remember about the x-intercept, that's where it crosses the x-axis and y is equal to 0. The y-intercept is just the inverse. It's where the line crosses the y-axis, and anywhere along the y-axis, x is equal to 0. So anytime we find our y-intercept, we're going to be using that information that x is equal to 0. So a really good trick we can use to graph lines is we can find both the x and y-intercept, because all we really need to graph a line is 2 points, and we can get 2 easy points by graphing the intercepts. We can use a checkpoint by finding a third ordered pair and plotting that as well, and seeing if the line goes through all 3 points. So here's an example. They give us an equation, negative 2x plus 4y is equal to 0. First we're going to find the x-intercept. Well, again, at the x-intercept, remember y is equal to 0. So just remember x-intercept, we set y equal to 0. So all we got to do is put y equal to 0 in this equation, like they did here, and solve for the value of x. And here we get x is equal to negative 6. So we got 1 point already. X is equal to negative 6, y is equal to 0. Negative 6, 0. That's one of our points. The second point we want to get is the y-intercept. The y-intercept, we let x equal to 0. Remember, x-intercept we let y equal to 0, y-intercept we let x equal to 0. So when we set x equal to 0 in this equation, it cancels that out, and we solve for y, and y is equal to 3. Now we have a second point. We said x is equal to 0, y is equal to 3. So we have two points, the x-intercept and the y-intercept. The third point is more just a check, just to make sure we didn't make a silly mistake. And we do this by finding an ordered pair. So usually one of the easiest numbers we can substitute in is letting x equal to 1. Since it's not the x-intercept, so we can't let x equal 0 again, because we just get the same answer. So we got to choose a different number other than 0, and 1's always a pretty easy number for us to work with. So if we set x equal to 1, plug 1 into everywhere we see x, solve for y is equal to 3.5. So then our third order pair, or third point on this line, is going to be 1, 3.5. And now we can just plot these out. Remember, our x-intercept at negative 6, 0, our y-intercept at 0, 3, and then our checkpoint at 1 and 3 at 3.5. Sure enough, the line goes to all 3 points, therefore we've graphed our line good. We solved everything good on that problem. We're going to do the same thing here. Use intercepts to graph this line. Remember, when we're finding the x-intercept, let y equal to 0, we get 3, 0. When we're finding the y-intercept, we let x equal to 0, and we solve for y. We get 0, 4, so we got 2 points. The next thing, we would like to always do a checkpoint. So we can set x equal to 2, and that was kind of just an arbitrary number. We could pick pretty much any number you want to choose here for the checkpoint. They like to choose little simpler numbers, as long as it's not the x or y intercept values. So we set x equal to 2. When x is equal to 2, y is equal to 1.33. So we got our third checkpoint 2 comma 1.33, and when we plot those points, we get 1, 2, 3 points plotted. Sure enough, the line goes through all 3 points. Therefore, it's a good solution. Talk a little bit about vertical and horizontal lines. These are special cases, and we'll talk, and we'll see that when we talk more about slopes. Next time. But horizontal lines, what this means is wherever our y-intercept is, that's the value. That's going to be the equation of a horizontal line. So y is equal to b. That means y is going to always equal that value. Okay, so it's going to be a horizontal line. When we have an x equals to a constant value, or a vertical line, all we're saying is x is going to always equal that amount, no matter what the y is. So those are generic equations for vertical and horizontal lines, and they'll always have this shape. Anytime you see y is equal to a number, or x is equal to a number, the y is equal to a number is going to always be a horizontal. The x is equal to a number is going to always be a vertical number. So here's an example of one of those. Graph the linear equation y is equal to -4. Remember from this last guy, y is equal to a number. So we say, oh, y is equal to numbers. It's going to be a horizontal line. And sure enough, whenever we graph that, we just have to say, okay, where is y equal to -4? Well, so y is equal to -4 everywhere along the -4 y value down here. So it's going to be a horizontal line that goes through -4 of y. The next one, x is equal to 5. Well, remember from our little trick again, x is equal to number, x is equal to number. That means it's going to be a vertical line. So this vertical line is going to be okay everywhere x is equal to 5. X is equal to 5 everywhere right at the x equal to 5 coordinate, and it goes vertically up and down. So that's a vertical line at x equal to 5. Remember that the graph of y is equal to b is a horizontal line. The y-intercept is your b value. Okay, that's very important. Hopefully that's pretty easy to remember, but since y is always equal to since the value is always equal to that constant value of y, of course our y-intercept is going to also be 0, because the x-coordinate is 0 at that point, and our b value of our equation. Consider the graph y is equal to 2. This is a horizontal line, and the y-intercept of is equal to 2. So again, if we have a horizontal line, y is equal to 2, we know it goes horizontal through everywhere y is equal to 2. Of course, our y-intercept is going to, so this line crosses the y-axis at the point 0, 2. Vertical line, that the graph of x equal to a is a vertical line. The x-intercept is a, so the same thing as the y-intercept. Everywhere the x is equal to that value is going to be the line, and of course it crosses the x-axis at the y is equal to 0, right, because there's no y height there, and at our constant value of our equation. So here's an example, x equal to -3. We know it's a vertical line at x equal to -3 up and down. Well, of course it crosses the x-axis at x equal to -3. So that's going to be our x-intercept. And lastly here, just a summary. When you're graphing, it's always helpful to use intercepts because those are pretty easy things to do. Find the x-intercept by letting the y equal to 0 and solve for the value of x. And remember, your point is going to be the x you solve, comma 0. Find the y-intercept by letting x equal to 0 and solve for y. So your answer out of this one, points to this one, should be 0 for your x, comma the value you get for your y. Find a checkpoint. You can choose any random number. Usually small numbers are easy. And then graph all three and make sure the line goes through them. So hopefully you guys have a good week, and see you online.